right, I think we can start. Welcome to the EDUC Infra webinar. I'm Natalia Gaidarenko, and I'm here with Darwin Marcelo, Project Director, and Fabien Nugier, Senior Research Engineer. This is the first session of the webinar series in light of the Green Infra months, and over the course of this month, we will present the work we have been developing on climate impacts and risk. And today we're looking at transition risk in green infrastructure investments. We have 1 hour, 45 minutes of which Darwin and Fabien will talk you through the topics of the webinar, followed by the 15 minutes of Q&A. Please leave your questions in the Q&A section and we will answer them after the presentation. And now I hand over to you, Darwin.
Thank you, Natalia, and thank you everyone for participating in this webinar. Let me start telling you about Inframetrics by EDUC Infra. So first, Inframetrics has academic roots. Inframetrics is designed to produce analytics based on large and representative samples and using academically validated approaches rooted in modern financial theory and economics. Inframetrics has been created on the foundation of a decade of research on unlisted infrastructure investment at EDUC Business School. EDUC Infra provides market indices, benchmarks, and valuation analytics for investors in unlisted infrastructure equity and private debt. Our clients include asset owners, asset managers, consultants, asset valuation professionals, pension funds, and among others. EDUC Inframetrics track thousands of investments in more or less 25 countries over the past 20 years. EDUC Infra key indices acquire recognition from the European Securities and Markets Association, ESMA. EDUC Infra a few years back embarked in a new and very ambitious project. We call it the Green Infrastructure Project. The climate risk in Inframetrics represents the results of these years of work and several $1 million invested in research and development and at EDUC Infra. The Green Infra project has a dedicated team of data scientists and experts on infrastructure, climate risk, finance. The climate risk and social risk products that we have generated are backed by scientific research, quantitative analysis, and a unique asset level data set. More specifically, in terms of the climate risk infrastructure metrics, we have divided this product in 4 big subcomponents. The first one, which is the one Fabien is going to be talking about today, is about transition risk exposure. The next week, we will be talking about physical risk exposure metrics, followed by climate stress tests. And at the end of the month, we will be talking about data for reporting. Needless to say that Inframetrics has unique data and a very user-friendly analytics platform, including the deepest available financial insights for unlisted infrastructure. And now it's going to include these climate risk metrics that we have developed over the past almost 3 years. Today with me is my colleague Fabien, who is a senior research engineer and data scientist in ESG. He is currently leading all the work in transition risk and the production of the data associated with it. His background is in physics and data science, and he also has a PhD in cosmology. He has vast experience in simulations, data analysis, AI, theoretical modeling. Myself, I'm Darwin Marcelo. As Natalia mentioned before, I'm the project director of the Green Infrastructure Project at EDUC Infra. Before joining EDUC, I was with the World Bank as program manager of the Quality Infrastructure Investment Partnership, and also was the lead of the Global Infrastructure Connectivity Alliance. Now I'm going to leave you with Fabien, who's going to walk you through the results of this amazing work on transition risk. And I hope you enjoy it, and please let us know your questions in the chat button. Thank you. Fabien, over to you.
Thank you very much, Darwin. Please give me a second. Right. Okay, so indeed, we'll go through the transition risk today that we have been developing models on. And after that, we'll go through use cases at the asset level and portfolio level. And we'll conclude with some remarks and some questions at the end. So this is a snapshot of the what you will find on the platform. And just give me a second. Right. And yes, so on the platform, you will find actually so different products, market indices. When you click on this section, peer group benchmarks to compare the different types of investors, fund performance benchmarks as well, deal and valuation analytics, and a section called asset search and due diligence. And in this section, you'll find actually your metrics on climate risk in one tab that I will show after. And finally, you can find also research papers in the last section. So all research is based on TICS. They are taking part in every aspect of our modeling, actually, and TICS is the standard for infrastructure investment classifications, and it's used by multiple investors, as you probably know. And it contains 8 industrial superclasses, which go from IC10 to IC80. And within those superclasses, you have different subclasses, 101 of them now. For example, IC60 1010 is airports, and 2020-10 is potable water treatment. So Inframetrics will now have those climate risks that we have been modeling for more than 700 assets. And they are covering all the superclasses, and they're also covering 23 different countries. So it's global, well, very, very large coverage all over the world. And finally, well, indices that we develop, such as Infra 300 and Infra 100 and others, rely on TICS. So you're going to see a lot of concepts relating to TICS in this presentation. Right, so let me move now to transition risk. So transition risk is the set of financial risks which arise from adjusting to a lower economy, lower carbon economy. And so it contains policy and legal risk, such as the effect of carbon pricing, new regulations, which can lead to some assets to be stranded, and possible litigations. It contains also technological risk, such as disruption from new technologies that use less carbon, or potentially failures of some of these technologies as well. It contains market risk, which is also directly relating to changing behaviors of consumers and also the availability of raw materials. Some of the infrastructure we are looking at depend on raw materials, so they may be impacted as well. And it depends on reputational, there's also reputational risk in financial risk of transition risk, which relates to consumer preferences. And as for the transition risk, it's both relating to climate impact and climate risk. As you know, there is the concept of double materiality. So not only climate change is going to impact the value of assets, especially also through physical risk, but companies have an impact on climate. And that is why we study the carbon footprints of those assets. And for GHG emissions, including carbon, we usually split those emissions in 3 different types. The first one is direct emissions, the Scope 1 emissions, which are generally the stationary sources of emissions and vehicles that may be owned by the company. There are also Scope 2 emissions, which is the indirect emissions from the purchase of electricity, heat, and cooling. And finally, Scope 3 emissions, which are the hardest to catch and as well to model, which describe the emissions, the indirect emissions from upstream and downstream supply chain activities. So let me now describe roughly how our models work. So first, we rely on data. So we use different sources. We use sustainability reports data, manually retrieved data, public, private data sets. We also use geospatial and traffic data. And finally, for the financial data, we use, for sure, inframetrics. So we developed those models. I probably have to thank also Nishta Manosha, my colleague, for helping with all these data sets and the rest of people at EDIC Infra that help us on the data. And so one type of models that we have is the statistical approach. So it's quite simple. We have emissions on some assets within a certain fixed class, and we also collect different characteristics of those assets to better understand the operations of those assets. And we can then build models to predict the emissions of assets for which we have the same characteristics, but no reported emissions. So this is what we do for some of the infrastructures. For example, you could have Scope 1 and 2 emissions of container ports, which are computed this way. And second approach is more physical-based approach. So in that case, you don't use reported emissions, you just use asset level data such as usage or traffic. Again, anything that represents the level of operations of those assets and potentially also the size of those assets to understand, again, how many operations happen there. And we build models on top of that to get emissions, and this involves theoretical considerations based on the literature. So this can be emission factors or capacity factors, etc., to estimate better the emissions. So an example of this is Scope 3 emissions from flight distance data, in which you use some variables to estimate carbon, but you don't actually use reported emissions. All right, so having these models, we can now build different metrics. So the first metric we have is the absolute emissions. So Scope 1, Scope 2, 3. Scope 3 is a bit less available, but we still have it in a lot of cases. And Scope 1 plus 2 and Scope 1 plus 2 plus 3. So you can get that at the asset level, but you can also aggregate this data at the peak segment level or the index level. Also, we have from inframetrics, as I mentioned earlier, the financial data. So we have total assets, equity price, enterprise value, revenue, and we could have much more. And we combine this with emissions to get carbon intensity metrics. So we take the scope emissions and we divide by any of those financial metrics to evaluate the efficiency of those assets. So again, we have this available at those 3 levels. And finally, we use Scope 1 plus 2 emissions as it represents quite well the emissions of the assets. And Scope 3 is more particular, more difficult to catch. So we take Scope 1 plus 2 emissions and divide by revenue. And we use this to establish a ranking of those assets within a superclass. So within IC10, within IC20, etc. And this is available at the asset level. All right. So what are the key features of our predictions? First, they measure the risk at the asset level. They are based on expert knowledge here developed at Infra. They are sector specific and also technology specific, and they use different variables. Also, these intensity metrics that we derive from the emissions and financial data, they are directly usable as financial ratios to assess the transition risk on those assets, and for some portfolios as well. So this answers to the need of having portfolio level proxies and the bottleneck in reporting transition risk. And so this can really help the investors to report emissions and the transition risk of their portfolio. Finally, so this transition risk metrics can be combined with other metrics such as physical risk metrics. So for that, you will have to attend next week's a webinar by Hugo and Darwin Marcelo. And you will, so we can also use, so physical risk and transition risk compose the, when you consider them together, you have the climate risk. So combining both, as it will be shown next week, helps you to actually estimate the climate risk of your assets. And finally, those risk metrics can be used as a basis for climate scenario stress tests. So for this, you can see in 2 weeks the webinar by Bertrand Jays and Abhishek Gupta. And last as well, those metrics can be used with other types of data, such as the unit of production or services of those assets. And this can be used as well to estimate the distance to EU taxonomy thresholds. So these are our metrics, and they are available at different segments. So we are covering right now more than 60 TICS categories. We have between 500 and 600 assets which receive emissions predictions. And those assets cover 23 countries in Europe, Americas, and Asia Pacific. And finally, you can assess those emissions by TICS, either at the superclass level or the subclass level, like you can see in the parentheses here. So for example, you could have look at the emissions at the power level for gas power plants, coal power plants, or wind farms in the renewable superclass. Right. Okay, so let's move to asset level predictions now. So this is the platform, what you'll see in going in asset search and due diligence section. And this is for the gas-fired power plant type of infrastructure. So you have 6 power plants here. And what you see on the left is the different metrics with a unit. So we have the absolute emissions of scope 1, 2, and 3. And we have the first intensity metric, carbon intensity, so emissions divided by revenue in million US dollar. And you have other metrics below. Now, if you look, for example, at the mean over this TICS category, what you find is a mean of, which is this value of 797,000. And what you have here is 0 scope 2 emissions, because those are gas-fired power plants, so they don't have direct consumption of electricity. They generate their own electricity. And scope 3 is also 0 because the consumers receive electricity, so there is no emissions generated from the usage of their services. So you can then look at different assets based on this mean. For example, you could use the median as well. And what you find is that 4 assets are above the mean. So those assets are emitting carbon in direct emissions, are emitting more than the average. And if you look at this carbon intensity by revenue, what you find is one of these assets is less efficient as its value is higher than the mean. So among those 6 assets, probably you would care more about this asset and you would maybe do further analysis on this one to know if that's the best investment you can make. Now, if you look at this line here, you have scope 1 plus 2 divided by revenue. And as I said, this is used to establish the ranking between those assets. So when you go back to the top row here, what you find is that the ranking corresponds to the values you have here. So this asset receives quite a high value here. So it is classified as very high transition risk exposure. All right, so this was for single asset comparisons, either to the mean, but you could also compare the assets to each other. And these are the predictions that we have from our models. So we have, like I said, between 500 and 600 assets covered. And here you have the different superclasses, so the sectors, and scope 1 at the top and scope 2 emissions at the bottom. So you can see that renewables, for example, have neither scope 1 or scope 2, except for a few of them. You can see also, like I said, that there's no scope 2 for those fossil fuel power generation assets. And you can see that transports as both scope 1 and scope 2, and as well, we have network utilities, etc., social infras. And so what is important to see here is that you can use inframetrics on this large sample covering different sectors and use those sectors as benchmarks, or use, for example, the mean, the median, or the quartiles to see if a single asset is emitting more than the rest, and you can do that as well for the intensity metrics to see which asset is more efficient. And this is critical for making investment-informed decisions based on emissions. All right, so I'll give you a second to look at these plots. So what we have here is scope 1 emissions on the left versus scope 2 emissions. And what you see is there is generally a correlation between scope 1 and scope 2 emissions. And while there's a few of them, like I already mentioned, which have no scope 2 emissions or no scope 1 emissions, and renewables don't have any of these. And what you see here as the size of the bubbles here represent the total assets. So what you see is that the largest assets usually have the most scope 2 emissions and scope 1 emissions. Now, if you look on the right side, what you have in the X and Y axis is the carbon intensity by revenue for scope 1 and scope 2. And so what you see is the efficiency of those assets. And roughly speaking, you can see that several of those large assets moved from the top right box to the kind of the middle of the plot. And this seems to show that those large assets are actually quite efficient, or at least they are in the average when it comes to being efficient, even though they emit a lot of emissions directly. What you see, on the other hand, is that some of the assets, which were smaller assets, do remain in this top right corner. And that means that those assets not only were high emitters, but are also quite inefficient if you compare to revenue. And that means that probably in terms of investments, those are more a concern, and those may be requiring more checks before investment. Right, so here on these plots, what you can see is the revenue against the total assets. And the size of the bubbles represent respectively scope 1 and scope 2 emissions. So what you see is for both Scope 1 and Scope 2 emissions that there is a strong correlation between revenue and total assets. I'm sure it's not a surprise for you. What you see as well is some assets still generate more revenue. This is the case of the power generation here. And what you can also see comparing the two plots is that the Scope 1 emissions predictions are much larger than Scope 2 emissions. So while we can still look in more details into the different assets, so you can see that from the colors that they are different segments, but that's basically the main point on those graphs. Now, here, if you look at revenue against Scope 1 and 2 emissions divided by revenue, so the carbon intensity, the efficiency, if you want, of those assets, what you first see is logically from the bottom left to top right, you have more emissions. So naturally, you have bigger bubbles here because the bubbles represent Scope 1 plus 2 emissions. But what is interesting to notice, and on the right side, you have equity price, so the equity price and the intensity by equity price, basically more or less the same shape. But here, looking at the value and the valuation of those assets, what you see in both cases is kind of a linear trend. At least it appears as well for certain type of assets. If you look at the brown bubbles, you see this line quite clearly. And what this shows is that the higher the revenue, the more efficient those assets seems to be. And that's the same with the valuation. So the higher the valuation, the more efficient those assets appear to be. Now, for sure, there are differences. And if we look at the different boxes here, what we get is, so just to go from the start. So these boxes represent the inefficient assets in terms of emissions. And those boxes are the efficient assets. Now, here we have large revenue. So ideally, maybe the most interesting assets are those that generate the highest revenue and being the most efficient in terms of emissions. So you see, they still have absolute emissions, which are not the smallest, but usually not too large. Now, on the opposite box, what you have here is the less efficient assets and less generating revenue assets. And you can see that they generate more emissions. So they would probably be the least interesting. And here we have the assets which generate high revenue, but are quite inefficient. So yeah, we have a similar pattern on the equity price, but what may be interesting to look at here is the difference between the two. So the revenue would be more closer to the operation, the level of operations. By the way, these plots are all for 2022. And so here you see the revenue for 2022, and here you have a valuation which represent a longer time scale. And what we seem to see between those two plots is that some of those assets which were here moved back here. And so that seems to indicate that their valuation is lower. And this may well be because of their high emissions, absolute emissions, and their low efficiency. And now what we see as well from the bottom, those plots, those points here, you can see that some of them have moved to the bottom right box, and that means that these assets, which were highly efficient and low direct emitters, are quite valued, especially in this part of the plot. So that also reflects on the fact that emissions, carbon intensity do correlate with the valuation. So this is interesting to explore. And now, finally, if you're interested in a more granular description, you can look at data within a superclass. So on the left here, you have fossil fuel power generation, and on the right side, transportation. And just to be quick on those, basically what you find is that this part is the high efficiency assets. And you see that the bubbles are larger, and the bubbles represent the valuation here again. So you see that those valuations seem to, high valuations seem to indicate a high efficiency. And well, between the two direct emissions, we don't see so much here. So maybe there isn't so much of interest in splitting the two populations. And what we see on the transport side here is quite similar and maybe even more apparent. So what you see is this box is the high efficiency, low direct emissions. And you see the valuations are pretty high. The bubbles are quite large. While on the other hand, here you have low efficiency, high emissions. And well, the valuations are also quite high, but there are less assets that we find here. And well, that may indicate actually assets which are problematic from the point of view of emissions. And here we have assets which emit a lot of carbons, but are quite efficient. So, and you can see the valuations are very large, and this probably indicates assets which are, well, quite mature and emit a lot because they have a lot of operations, but at the same time are quite efficient in delivering services. All right, so now we will move to the portfolio level section. So at the portfolio level, what is interesting is to look probably at the sectors. So inframetrics can be used to proxy actually the portfolio and the assets in a portfolio, especially for very large portfolios, for which it would be very difficult to estimate the emissions for every asset. So you can use inframetrics to look at the asset classes and look at the emissions. So this table shows the intensity metrics by revenue, enterprise value, and equity price for transport and for Infra 300. So you can see very different averages, that's median values. And this can really help to assess the emissions of a portfolio by looking at the different values and maybe changing the composition of the portfolio. Right, and this would also help for reporting, as TCFD requires the transition risk metric, and all data could really help in reporting. All right, so let's focus on one index from Inframetrics. This is the Infra 300 index, which represents globally the different infrastructure assets, and which is equally weighted. So here you have the composition of the Infra 300 index. So there is transport, renewables, utilities, etc. Power generation as well. And you can see that, so these are direct emissions. So most of the emissions here come from power generation, followed by LNG, gas pipelines, etc. And then utilities, water, water treatment, and also a bit of transport. So in total, the estimate is about 60 megaton of CO2. And we can have the same, doing an equally weighted representation of the intensity of this portfolio. And what we find is that the fossil fuel power generation, which was generating high revenues, do have higher efficiency, so lower carbon intensity. So the part of the pie here gets reduced, and mechanically we also get the rest, which takes a bigger amount. So So we have gas distribution and all the other assets which take a bigger part, as they also have their own carbon intensity. So here I'm presenting the Infra 100 Core Plus. So this is only 100 assets which have the highest valuation. And you can see a composition of the emissions which is a bit different. So here the energy and the IC40, energy and water resources, was second, and it's now first. And the rest is kind of similar. And you can also study the carbon intensity of the portfolio. And here we see that power generation then becomes first, probably because of different population of assets composing the index, because as I said, it's made of the highest valuation assets. And the total carbon emissions of this portfolio is more around 20 megatons. So let's go through a few final remarks. So those metrics, transition risk metrics, and the other metrics that you'll see in the coming weeks, which are available in Inframetrics, will help infrastructure investors to proxy the portfolio and estimate the exposure of those portfolios to climate risk without actually going into the assessment of all the assets in their portfolio. This data can be also very useful as we have different comparables. We have multi-sector coverage. We also have different TICS categories. We also have the medians and many ways to compare the assets, also by region. This climate metrics will help also documenting the climate change expected and extreme outcomes of portfolios. So this is also useful for risk management. And finally, this data can be used for proxies for reporting and regulation. All right, so you can access the Inframetrics well, most of our predictions will be in this part of Inframetrics, asset search and due diligence, and this tab that I've shown before, but it could appear also in other parts of Inframetrics. And you can visit our website, and if you don't have access to the platform, you can also click on this link. And yeah, thank you very much for your attention.
Thank you, Fabien, for your presentation. Very insightful, and I really hope that for the attendees, you know, it covers more of the inquiries they have. In parallel, we received quite a few questions, Fabien. So
Okay.
We still have a few minutes to discuss some of these questions. So I'm going to ask these questions until we run out of time. Okay. So let me start with this question. What's the coverage of the scope 1, 2, and 3 emissions data that you have produced? And if you could give us a little bit of an idea of what's the geographical coverage of this data?
Right. So the coverage for scope 1, 2, and 3 is like we wrote in the slide, between 500 and 600. So for scope 1 and scope 2, it's more around 600. For scope 3 is more around 500. And for scope 1, 2, and 3, I forgot the exact number. I should check again, but that's the intersection of these. So if I remember correctly, that's at least more than 400. I think maybe 450 or something like this. Well, yeah. And for the geographies, So we have 23 countries covered. The exact list I don't remember, but so they are in Europe, in Asia, and America.
Fabien, as a follow-up, maybe you can mention a little bit about the representativeness of the data that you have to use.
Right. So, well, like we have shown, so there was, I didn't comment on that, but for the Infra 300, we are covering about 75% of the assets with predictions. This may be improved in the future, reaching 100%. But since this index is covering the most part of the world and is representative actually of infrastructures globally, we are actually through the predictions representing the infrastructures globally for the emissions as well.
Very good. Thank you, Fabien. We have another question. For the simple asset analysis, does that take into account power generation capacity? I guess this question refers in particular to power generation, the estimation you produce for scope 1, 2, and 3 when it comes to power generation. Does it take into account power generation capacity?
Yes, we do take into account the power capacity. We also take into account the actual production, not in all cases, but yes, we also take into account the real production.
We also have a question regarding the scope 3 emissions. Will it be possible for you to maybe give us a little bit of an additional explanation of how you developed the estimation for scope 3? Now, considering that scope 3 is always like a tricky part, you know, when it comes to carbon generation.
Yes, indeed, it's a tricky part, and it's tricky. I mean, the main reason is simply because you can have so many different sources of scope 3 emissions. When it comes to statistical models, that's not really a problem. As long as you have reported scope 3 emissions, you can build a statistical model. One problem, though, is that scope 3 emissions reported are not always accounting for all the different sources of emissions, but this is a reality, and somehow this is something that probably among models, these are the models that require more work and getting complexified. But from the modeling point of view, there's no problem in just building a statistical models as long as you have good reported scope 3 emissions. Now on the physical approach, the type of models based on physical approach, this is sometimes more complicated if you don't have the relevant metrics to the relevant variables to predict those emissions, then it's very difficult. On the other hand, if you do have access to these characteristics of the assets, then you can probably do a better job than just developing a statistical model. So we published a paper last year on airport emissions, and what we found for the airport sector was actually quite ideal, because for airports, the scope 3 emissions had a real hierarchy in the different sources. So the main source for airports scope 3 emissions is the cruise of the aircrafts from one airport to another, and this is about 10 times more than the LTO cycle emissions, which is so the takeoff and landing of aircraft at airport locations. So this hierarchy is good, because then you can directly, I mean, more easily estimate at least the bulk of emissions. And yeah, and when it comes to airports, LTO emissions is usually the only one being reported. So having an approach based on a physical approach can really help in such case.
Very good. Fabien, I guess we still have time for one more question, and it's regarding the metrics that you've generated. Could you tell us if you have generated any kind of ranking at the superclass or sub-infrastructure level by emissions or carbon intensity?
Right. I didn't show in the plot, but yes, we can definitely do that. All these are computed for the assets. So once when we have the predictions, then we can rank all the assets. So yeah, we can rank them with respect to each other, or probably it makes more sense to rank them within a sector. And yeah, we can produce those rankings without problem.
And there are a few other questions that I guess, because we're limited in time, what we can do is maybe I pass these questions to you, Fabien, and you send a separate email to the participants with the answers. This is the first of a series of webinars, and we invite you guys to participate in the other 3 webinars that we're gonna have during this month. The next one, very closely related to this one on carbon emissions, has to do with physical risk. So we really hope you can attend to this one, because part of what we're gonna do is to combine information from the carbon emissions data with physical risk and show the kind of analysis that you can produce using these 2 bits of information. Thank you, everyone. And thank you, Fabien, again for your presentation. And we hope to see you soon.
Thank you.